Hello everyone, I am Suprakash. Research Scholar, Department of Electrical Engineering, IIT BHU, Varanasi. Okay, everyone, let's try. For the today's topic, in previous class, I taught you about the Laplace. How can you use the Laplace in your circuit? And I taught some examples. Some and further, I taken some more examples to better understanding how can you use the Laplace in your circuit in more than one order. Like if more than one energy storing element is there, if in your question, then there is difficult to solve that question without Laplace, because of there is the differential equation is there. And then you have used to differential equation to solve differential equation for the response of the system. Okay. Yeah, suppose an RLC series circuit. How can you solve the find the current in a RLC series circuit? So a circuit, a three component, simply R, L, and C. VT, the supply DC source is there, not AC source. Same thing if there is AC source, then not there is not transient. Only we can use simply impedance to solve the find the current. But here the RLC series circuit at DC source. Then how can you find the current flowing through it? In this case, suppose in a previous say suppose if you want to try to solve this question by differential equation, then you use this one VT, KVL, KVL the circuit. Then this is minus VT plus IT into R, plus this is the inductor. It means G L dit by dt plus 1 by C integration of IT into dt. This is the equation in the time domain. L dit by dt plus IT into R plus 1 by C integration of IT dt is equal to Vt. This is the differential equation. How can you solve this differential equation? That is the problem. There are differentiation and integration both present in this equation. Also simply you can differentiate, you have to differentiate once again this thing L d2 it to eliminate the integration part. So this is d it by dt into R plus 1 by C it dt. is equal to 0. You differentiate the constant term Vt, it will be 0. Now you have to solve this question, this equation. That is a problem to solving this equation. Okay. Same thing, suppose if you try to solve by the Laplace, simply a voltage source and a resistor, a inductor and a capacitor.
Sir,
Yes.
sir, in the last step, dt will be dt will be cancel out now, sir. 1 by c into I of t. That's it. dt will cancel.
Oh, okay. Sorry. Dt is not there. Only it is there. Okay. Thank you. This is the voltage source Vs, Ys. This is R, same to same. This is Ls. This is 1 by Sc. And this is current is Is. In this case, simply if you use a KSPL, same Vs by S plus R into Is plus SL into Is plus 1 by Cs into Is is equal to 0. You can take a common Is. This will be R plus SL plus 1 by Cs is equal to Vs by S. In this case, Is is equal to Vs by S divided by of R plus SL plus 1 by Cs. This is the current, but this current is in frequency domain. You have to calculate this one or taken the inverse Laplace of this system. You take the inverse Laplace of this thing, then you will get the current in time domain. Vs by S, you can take a Cs as a common here LCM, and this will be RCS plus S square LC plus 1 divided by of Cs. S will be cancel out. This is the Vs into C. Vs by C into C divided by of S square LC plus RCS plus 1. Take LC common. This will be S square plus CC we cancel out, only R by L is there plus 1 by LC. CC cancel out. This is Vs by L only. S square plus R by L S plus 1 by LC. This is a quadratic equation. Okay. To make this one perfect square, we have to always add half of the s term. Which one is a coefficient of s? We have to add half of this one square and subtract the half of this one to make the perfect square. This will be s square r by l s plus this will be r by 2l square minus r by 2l square half of this one square plus 1 by lc. You can see this thing s square plus r by 2l whole square plus 2ab. This is the a square, this is the b square, this is term is 2ab. Always you have to simply add this term multiplication of that one s term half of this one square, add and subtract only, then we will get the final perfect square. This will be a is s, b is r by 2l square plus this thing is 1 by lc minus r by 2l square. This is the is. Suppose let the alpha is equal to r by 2l and beta is equal to root of 1 by lc, the root of this one. Alpha is equal to this one, beta is equal to this one. Then this equation will be simplified as s plus alpha square plus beta square. Okay, it means this one is vs by l 1 divided by of s plus alpha square plus beta square. It means 1 divided by a square plus s square plus something b square. Simply sine term, you simply multiplication of beta and division of beta can do, and then this will be a beta divided by of s square plus beta square. No Laplace of the sine omega t is omega divided by of s square plus omega square. It will be looks like that only. This alpha term makes this thing is e power of minus alpha t. This will be omega, simply adds alpha in terms of s. This is that means the inverse Laplace of this thing is vs, it is capital, it will be vt divided by beta l e to power of this one minus of alpha t into sine beta t. This is the current equation in RLC series circuit supplied by the DC source. You can see if you apply the DC source in RLC series circuit, then the current will be in sinusoidal in nature. But there is a doubt, I think. This RLC. And you know about the inductor and capacitor will not work on the DC source. Inductor will be short circuited and capacitor will be open circuited in DC source supply. But here you can see the current equation of this thing RLC circuit is in a sinusoidal in nature. How it will possible? If you apply the circuit, then you know about the in steady state it will be a resistor is same to same, inductor will be short circuited, and capacitor will be open circuit. This will not work. Well, it means the current will be zero in this circuit. Current will be zero because of the open circuit, due to the capacitor. But here, the current nature in the RLC series circuit is sinusoidal. Here is in terms of e to power of minus alpha t. What is meaning of this? This one is the exponential term. E to power of minus t, it means this will be decaying in nature. E to power alpha t, this is, will looks like that. At minus infinity, it will be 0. At plus infinity, it will be infinity. We put the minus infinity here, e to power minus infinity, it will be 0. We put the infinity, time is infinity, then this will be a 0. Infinity. E to power minus alpha t, this will be looks like this thing. Same thing here. This will start at box and at 0, infinity. If this is plus infinity, it will be 0. This will be minus infinity. E to power of minus alpha t. If negative term is there, at infinity it will be goes to 0. But in positive term, e power alpha, it means can taken as a mod alpha. No. To alpha, or you can say alpha is greater than 1. In the both case, alpha is greater than 1, not 1, less than 1. Greater than 0. If greater than 0, then this will be looks like that. If the alpha negative, that means it will be changed. If alpha is negative, then same thing, same form will be changed. This will be a e to power of alpha t. This will be e power minus alpha. That's why I write this one alpha is greater than 0. It will looks like that. It means this equation.
Sir,
Yes.
can you explain Laplace transform method one more time?
In this question.
Yes, sir.
Okay. Okay. Simply in RLC circuit, you know about the inductor and capacitor. Inductor is written as the SL in terms of L. S is simply you know about the j omega. And you know about the XL is XL is written as the j omega L. That's why in place of j omega, simply we can replace the S. Laplace S. SL, and capacitor is written as 1 by SC. Then you simply use the KVL. This will be a KVL, voltage source. Then this will be a resistor, inductor, and capacitor. This will be a simply multiplication of the impedances with the current is the voltage. Now take a common as IS. Then this will be R plus SL plus 1 by CS equal to VS by S. Constant and switching is there. Switching is there. Then you have to use the constant voltage as Vs by S. The voltage source or current source is written as Vs by S. Where is the switching is there present? Then Is is equal to Vs by S up to R SL by CS. And here you can take a LCM CS. That's why SS is cancel out. This will be Vs into S C divided by S square plus SC plus R CS plus 1. Then you have to common as LC, and this will be equation to makes this one is 1. Then you have to take a common as LC. That's why this will be a S square plus R by L into S plus 1 by LC. Then after SC should cancel out, this will be S square plus RLS plus LC. This is the quadratic equation of the current. You can find the anything from this one like zeta and all of thing, dynamic factor, frequency. This is the quadratic equation for the current. We have used this. I try to find the inverse Laplace of this thing. S square plus RL by R by L S plus 1 by LC. How can you find the inverse Laplace? Then you have used to make the perfect square, or you have to use to make the formula. You have formula only e power 80 sin 80 like that. Then you have to use makes this thing to fit your formula. How can you fit it? Then you have used to perfect square. So by making the perfect square, simply any system you simply use the half of a s term, half of the s term square, add and subtract. Half of r by l is r by 12. We have used to square and add and subtract. Then this will make the perfect square s plus r by 12 whole square plus remaining thing is given here. I simply taken this is, let the beta is this one, alpha is that one. Then after this will be Vs by L as L plus alpha whole square plus beta square. We know about the sin t. Sin function is the omega divided by s square plus omega square. If there is any term is added with s term, simply it will goes to the exponential term. Because of you know about the e power minus 80, Laplace is 1 by s plus alpha, s plus a. That means this thing is makes the e power 80. If alpha is 0, then this function is 1. Only sin t is there. Sorry, omega divided by s square plus omega square. So alpha is 0. If I put the alpha here 0, then this will be 1. Only sin omega t. Sin omega t is omega divided by s square plus omega square. Okay. Then if there is a alpha term is more, then simply use the e power 80, which one is a 1 by s plus a in multiplication with the sin term. Then this is the equation, current equation, which one in terms of alpha, exponential and sine. Then actually what it looks like that, e power of minus alpha t into sine beta t, or you can say it vt by beta t. Beta all other things is constant, so beta L. Inductor is constant, beta in the beta term all of the all the value is constant because of beta is the L, C and R. All is the constant term. Only variable is this thing. Actually, this current should be 0 at the DC supply. But if you use the same an RLC circuit in AC, in DC, this will be goes to 0, but it depends on the value of alpha beta. How looks like that. If beta is greater than 0, then this will be a underdamped system. How can you say that if beta is greater than 0? What is the beta? Beta is root of 1 by LC minus R by 2L whole square. This will be greater than 0. Then so you can simply square both sides. Then this will be 1 by LC minus of R by 2L square will be greater than 0. 0 square is 0. Then 1 by LC is greater than of R by 2L whole square. In this case, you can say this will be R square should be less than of 2 square is 4, 4L square, L will be cancelled out, 4L by C. If this condition is satisfied, if square of the resistance is less than or 4L by C, then the system will be underdamped. Why I am saying that? Because of you know about the zeta. Zeta is damping factor. You know about this one, damping factor. So decide the damping, over damp or under damp system. This will be R by 2 root of C by L. How can you find here? This will be R square by 4 is less than 4 by C. This is the R. If you take R square, take if this is a 4LC. If you want to find the R will be a 2 root of LC L by C. We take all of thing is left side. This will be R by 2 under root of C by L is less than 1. And know how this thing is theta. If zeta is less than 1, then what is the meaning of this one? If zeta is less than 1, then this will be underdamped. What is the underdamped? Underdamped it means it will start from maximum and goes to slowly 0. At infinity it will be or in the steady state it will be a 0. This is the underdamped system. Why it is be looks like that? because of the exponential term. We know about this exponentially. We start from 0, and what is the same thing, e power of minus t here, because of this is the minus t ut. Then if you take from 0, then this will be looks like that. That's why this whole function is looks like that, because of the exponential term. After some time period of time, it will goes to 0. You can say a steady state are in at infinity. Sorry. What happens if zeta is greater than 0 1? If same thing, zeta is greater than 1, it means here r square is greater than 4 by l 4l by c. R square is more than 4l by c. That means it not goes to 0. In that case, the current is overdamped, and overdamped system, it will be started from here and goes to unstable, like that. Same thing if zeta is equal to 0, it means r square is perfect equal to 4l by c. Or in some cases, it say that r is equal to 0. This is our another term, because of you know about zeta directly dependence on r by 2 root of c by l. If l and c is there but r is equal to 0, then zeta is equal to 0. Not meaning of this one, simply if zeta is equal to r is equal to 0, in that case you can say this is the undamped system. Same current, same circuit. If the resistance is not given in circuit, then the current in nature is about e power of, sorry, current in this the case we know about Vs by beta L e to power of minus alpha t sine beta t. If zeta is equal to 0, it means r is equal to 0. We know about alpha is r by 2l. R is equal to 0, it means alpha is equal to 0. Same thing, if we provide the alpha 0 here, then what happening? That Vs bt in time domain. E to power 0, something power 0 is 1. This will be only sine t. Only sine term is present. That what is the meaning of this one? What is the current nature in this system? Simply a sinusoidal. There is no damping. If no damping, it means oscillatory. This will be simply a sinusoidal, perfect sinusoidal. It never goes to zero. This current is never goes to zero. This is the you know about this is the DC source. A DC source applied to a LC circuit, when a inductor and a capacitor both are not worked on the DC source. But here you can see the current is sinusoidal. Current never goes to zero. It means the circuit will working. Circuit is working on DC. But this is possible only if the resistance is not there. If a resistance is there, that resistance is at the damping factor, and that damping factor is damped to current to zero. That damping factor is damped the current to the zero. But if the resistance is not there, then the circuit will be current will be sinusoidal. The same circuit is used if you know about the commutation process of the thyristor. If you learn about the thyristor is triggered once, it will not, it is uncontrolled. Then how can you switch off the thyristor? By this, the two process, uh, natural commutation and force commutation. Natural commutation, it means if the sinusoidal current is provided, it means if you work the thyristor in AC circuit, then AC circuit in the sinusoidal plus and minus is there, the negative term is block the thyristor, and thyristor is off. Then after it is on the next cycle. But in DC source, a DC source is constantly on DC source. Then how can you turn off the thyristor? That time the thyristor is not turned off by the DC source and by the natural thing. In that cases, it will use the LC circuit to turn off the thyristor in DC source by using a commutational circuit. Commutational circuit, same thing. Here current provided the negative. Same thing if LC circuit is the provide the LC circuit, and LC circuit makes the current is negative side. A negative current is never flow through the thyristor. That's why the thyristor will be turned off. This is known as the force commutation process of the thyristor. This same circuit is used in thyristor to turn off the thyristor. Okay. Okay, let's try the question first. What happening with the parallel circuit? Parallel RLC series circuit. So parallel RLC circuit is excited by a current source with a unit step signal. The voltage cross capacitor is equal to. I think same circuit I already taught in previous question, previous slide, previous session. Simply you have to take a simple take a comma b. First of all, you simply use to make the circuit in Laplace. Ut make the us by s. R, this is SL, where L is 1, that's why this will be 1, this is S, 1 by C, C is 1, then 1 by S. You have to find the voltage of VC. This voltage is, all our voltage is connected in parallel, that's why the all voltage is same. This node voltage is VC S, use the KCL, by KCL in the circuit. Incoming current in this one, US by S, US is 1, unity is there, that's why this will be 1 by S only. All thing is 1 1 1. This will equal to BCS divided by F1, this current, plus BCS divided by Fs, this current, plus, sorry, BCS is 1, that's simply use 1 divided by, this is the 1 by S. Oh, sorry. This BC is there. This is that one. You have to find this one. This is 1 by S. You can take a common as BCS. This will be 1 plus 1 by S plus S. Take a LCM as S in this right hand side. This will be S plus 1 plus S square BCS 1 by S. SS will be cancelled out. And what is the BCS? This will be 1 divided by of same S square plus S plus 1. This is not a perfect square. And how can you make the perfect square? Simply add square term of half this one. Add and subtract. S square plus S plus 1 by half square, 1 by half square minus 1 by half square plus 1. You can say this is a S plus half ka whole square, S plus 1 by 2 whole square, plus this is the plus 1, this is a minus 1 by 4, this will be 1 divided by of S plus 1 by 2 whole square, plus this will be 3 by 4. In this case, you can write this thing as root of square. This will be 1 divided by f S square plus omega square, like that. But this is not a perfect thing. In sinusoidal term, you know about the omega divided by f S square plus omega square is the, this will be root 3 by 2. We have to multiply root 3 by 2 and divide as root 3 by 2. Then this thing is sinusoidal. Then inverse Laplace of this is t, this is 2 by root 3, half of this one e to power of minus half t into all of thing is sinusoidal, sine omega is root 3 by 2 t. This is the answer. Capacitor voltage 2 by root 3 e to power of minus t by 2 sine root 3 by 2 volt. In first option. Why it is not cos? It is not cos because of here is not only constant term, not a s term. If s term is here present in numerator, then that time you have to make the sinusoidal Laplace of the cosine, not a sine. If s term is here, then make the Laplace of the sine. Oh, sorry, cosine. But here is a constant term, that's why I make the Laplace of the sinusoidal. Okay. Simply directly you have to convert in Laplace and Laplace you have to solve. So the next circuit, again second order circuit, inductor and capacitor is here. The circuit shown below, the switch is moved from position A to B at t is equal to 0. This is previously is connected to A, then after it is connected to B as t is equal to 0. And how can you make the circuit? How can you find the solution of the circuit by using the Laplace? Can you try to make the Laplace circuit? Yes, okay. If you want to try this question to solve by the Laplace, then you have to first of all try to find the initial condition, initial value of the element. You can't the because here the switching is there present. It makes the two circuit. Then how can you solve the Laplace by taking only one circuit? With Laplace we can solve by taking one circuit only. But here is a switching is there. It means the circuit will be two circuit. The ones are before the t is equal to 0 and ones are after t is equal to 0 another. Then in that case, first of all you have to find the initial value of the element. Then after find the initial value, then you use to make the circuit, proper circuit in Laplace domain. Then after you can solve the Laplace to find the final answer. Okay, how can you find the initial value? You make the circuit at t is equal to 0 minus 0 minus this circuit is connected to this one. And know about this inductor will be short circuited. This is 4 ampere. This current IL is 6 ohm. This is 2 ohm. Okay. Capacitor will be open circuit plus minus of 12 volt. This circuit is not completed. That's why this voltage is 0. And say VC 0 minus voltage is equal to 0. So it's the same as VC 0 plus at initial condition. What is this current? This current is IL 0 minus is the same as IL 0 plus. This 4 ampere current is divided into two parts, 6 ohm and 2 ohm. So to find the initial value of this current is you to find this one use the current divider rule. Total current and opposite of resistance, it will be 6 ohm divided by of total resistance. 6 plus 2 is 8. This will be a 3 ampere. Initial current of the inductor is 3 ampere. Initial voltage of the capacitor is 0 because the capacitor circuit is incompleted. This is not closed circuit. If this part is connected anywhere, then you can find the you able to find the voltage of the initial voltage of the capacitor. But this is the not connected to one terminal is not connected anywhere. That's why the voltage is 0. Now all the thing is initial values find found them make the circuit Laplace domain. After t is equal to 0, that means this circuit is simply connected to this one. This is like looks like this. In this case, SL is here, 1 by CS is here. All things resistance is same. A inductor and a capacitor, then a resistor, a voltage source. This 2 ohm resistance is not connected. No meaning of this one. After t is equal to 0, only 6 ohm resistor is here and a current source is there. Which one is 4 ampere. This is 4 by S. This is a 12 by S. This is 6 ohm. This is SL. This is 1 by CS. And resistance is 14 ohm. But here initial value is there of the inductor, then you use the initial current. Initial current of the inductor is 3 ampere. Then this will be a 3 by S. Okay. This is a circuit after t is equal to 0. You have to always make the circuit after t is equal to 0 to find the value because of that many approx almost always if I am asking the value after t is equal to 0. That's why you have to make the circuit Laplace circuit after t is equal to 0 to find the value. Okay. Here you can see this is a current source parallel with some impedance. This is also current source parallel with a resistance. You can use the source transformation. If you transform this one, this source, then what happening? Know about the transformation. A current source parallel with resistance is, suppose this is the I, this is R, converted in a voltage source with multiplication of these two IR into a resistance connected in series, which one is the same as the this circuit. Okay, you can something multiplication of these two 3s by and SL, multiplication of 3s into 3 by S into SL. SS will be cancelled out. Oh, why it happening here? 3 by S into SL, it will be 3L. The voltage source is 3L. Inductor is same as inductor and a voltage source. Arrow is here. That side is positive. This is 3L. And this inductor is SL. Then after this is a capacitor, a resistor and a voltage source. This is also transferred 4 by S into 6. This will be 24 by S. The voltage and resistor is same 6 ohm. Arrow is positive. 24 by S, 6 ohm. This is 12 by S. This is 14 ohm. This is 1 by CS. You have to find the current. This current. IL is same as this current. Asking about the current. IL. This current. This current same IS only. That's why you can find the IS. Use the KVL. I started from here. So minus 24 by S plus 6 into IS plus SL into IS minus of 3L, then plus 1 by CS into IS plus 14 into IS plus 12 by S is equal to 0. This is minus of 24. Okay, this is the plus of 12. Total is minus 20 or minus 12. IS, 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 IS. I have taken as a common. This will be 6. This is SL. This is plus 1 by CS. This is 14 minus 24 by S plus 12 by S. It will be a minus of 12 by S. This is a minus 3 by L. These two are the constant. Put the value of L and C. What is the value of L in the question? L is 2 Henry, C is 0.02 Farad. L is 2 Henry, C is 0.02 Farad. I is 6. 6 plus 14 is 20. SL, L is 2, this will be 2S plus 1 by C. 1 by C, C is 0.02. This is 1 by 0.02. It will be 50. 50 by S is equal to, this will go to our right hand side, and this will be a 12 by S plus 3L, L is 2, this will be 6. Take a LCM as S, this will be 12S plus 2S square plus 50 is equal to, you can take as S here common also, 12 plus 6S. SS will be cancel out, then IS is 12 plus 6S divided by, this one next is 2S square plus 20S plus 50. You can take 2 common from both numerator and denominator. In numerator it will be 6 plus 3S divided by of S square plus 10S plus 5. Sorry, 2 common is this one, 50 is, it will be 25. This will be S square plus the 5 square plus 5 into 2S, it will be 10S. S plus 5 is whole square in denominator side, you can say. Right, taken as 3 is common in upper side, this will be a 2 plus S divided by of S plus 5 whole square. This is S plus 5. You simply add S plus 2 here, add plus 3, N minus 3 to make the S plus 5. This will be S plus 5 divided by of S plus 5 whole square minus of 3. I separate this thing. One S plus 5 is cancelled out in this case. That's right. This will be 1 divided by of S plus 5 minus of 3 divided by of S plus 5 square. You have to take the inverse Laplace. IT is 3. S 1 divided by of S plus A, it will be e to the power of minus 80. It means here is a 5, is a 5t minus of 3. This will S plus 5 whole square. Whole square is there, that means t is there. T e to the power of minus 5t. It means 3 minus of 9. You can take a common e power of minus 5t. This is the answer. 3 minus, so 3 minus 9t. 3 minus 9 t. 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 3 minus 9 3 minus 9t e to power of minus 5t.
Sir,
Yes.
can you explain this problem one more time?
Okay, okay. Not worry. This type of question, like if there is a switching at t is equal to 0, then for the solving this thing in Laplace by the Laplace, then simply use to make the circuit after t is equal to 0. If you make the circuit after t is equal to 0, then it means you have to know about before t is equal to 0. What happening? If there is any initial value is there, then you have to take in this one. Then before t is equal to 0, you have to make a circuit and find the initial value. If you got the initial value, once you got the initial value, then put the initial value, makes the circuit, a complete circuit. Then after, if there is a useful of conversion of the sources there, then you can converge. If there is a no meaning of the conversion, then don't convert. But here, in almost all cases in the inductor, you have to convert the source transformation, makes the voltage source instead of the current. That's why I make the circuit as a, this is the initial voltage, initial current 3 by S is here, SL, Laplace of the inductor 1 by CS, Laplace of the capacitor 14 ohm, same to same, 12 volt, it means 12 by S is there, and this is 6 ohm, this is minus, this is a 4 by S, current source is 4 given in the circuit, and this is the Laplace of the or circuit at after t is equal to 0. Okay, then simply I use the source transformation to make all the voltage source. Here is all thing is in a simple KVL loop. The conversion of this thing 3s in
Sir,
Laplace. Yes.
sir, here we used Laplace transformation method. Instead of this, we can use time domain analysis also.
Yes, you can do a timed domain also instead of Laplace.
Sir, can you do it with time domain analysis also?
I think it will. I have already done in the previous session. If you want, I can solve this question again.
Okay, sir.
Okay. Same thing, if you want to solve this thing, then you have to put this and make the circuit same in time domain. Then you have to solve in time domain. It will make some more time to I think from this one, because of here the inductor and capacitor both are present. That's why if a two orders system in your circuit, then simply use the sorry, Laplace. Laplace easy in that cases. If the single circuit is single single order circuit is there, then simply use the time domain.
Okay, sir.
Yeah. Okay, then after Laplace, simply use the source. Simply calculation is there only after the conversion of Laplace. Here is simply take a common, and after that here 3 2 plus 5 2 plus s divided by s plus 5 whole square. If the whole square term is there, that means there is a t multiplication because of the Laplace of t is 1 by s square. This is the s square, but 5 is there. s plus 5. If something is plus or minus, then we have used simply exponential term it will become. If only s is there, then no exponential term. If s plus something, then e power of minus something. If s minus something, then e to the power of plus something. It will, we have to solve this one like that. Okay. Square term, it means t is there, remaining thing is same, e to power of minus 5t, e to power of minus 5t. They are too difficult to find the simply time constant in time domain. Time domain simply you have to use the differential equation. You have to solve the differential equation to find the value. Simply RLC circuit. You can see this is the RLC circuit. RR will be added RLNC circuit. It means you have used to solve the this circuit by using a differential equation, the second order differential equation. Okay, the next one in the circuit
Okay, sir.
given below. Yes, given below the switch is moved instantaneously from position A to B at t is equal to 0. The value of Vt at t is equal to 1 second. Okay. Same thing, you have to first find the initial voltage and initial current in this case. Then after it will be make same RLC circuit. At t is equal to 0 minus. This what happening at t is equal to 0 minus. Again second order system. At 0 minus the switch is at position A. This inductor will be short circuited and capacitor will be open circuited. The 5 ampere, this is 4 ohm, and this is a Vt. It means 0 at 0 minus. What is this voltage? In this case, this is
Sir,
yes.
sir, here a current source is parallel with a resistor, and we change it as a voltage source in series with a resistor, or we can keep like that only.
You can choose. You can do.
The
Because
value remains constant. No,
okay, okay. Because of here, actually here is the whole current is passing through this only. Because of here the open circuit, then there is no
n-
no need to change. If there is a complicated circuit is there, then to solve that one, then you have to choose the source transformation. But here is a simple circuit, all the current is flowing through the 4 ohm only. That's why this voltage is same as this voltage, because of this is connected to the across the voltage capacitor. This voltage is 4 into 5 is 20 volt. The same thing you can say this voltage is 20 volt. This current is IL at 0 minus it will be 0 because of there is no current passing through this one.
okay, sir.
Yes. If there is no current, that means the inductor current is 0, only voltage source is there for the capacitor initial voltage. It will be 20 volt. Okay. Then what happening at t is equal to greater than 0. First of all, I draw a circuit in time domain. Then after I replace this one, convert this one into Laplace. This circuit is close to this B position. It means this circuit is no meaning because of this one open circuit. This current and a resistor. Also, sorry, a resistor in parallel, not series. This open circuit. Here a capacitor. This is 5 ampere, 4 ohm. This is the 10 ohm resistor. Okay. This capacitor and a voltage source is there. Voltage source is polarity will be same. This is a positive and this is current negative. Voltage is 20 volt. It means 20 volt. Capacitor C, L and R. Inductor is 2.25 and capacitor is 0.04. 0.25 and capacitor is 0.04 farad. Okay. Simply again it will be RLC circuit with initial voltage of 20 volt. Let's try convert into Laplace. In the resistor is same, inductor and capacitor will change. A resistor and a inductor, then capacitor, then a voltage source, 10 ohm, 2.5 S, 0.25 S. This will be C, 1 by SC, 1 by 0.04 is 25. That's why this will be 25 divided by of S. This is 20 volt. This is 20 initial voltage, 20 divided by of S.
Sir,
Yes,
wh- why the capacitor value is 25 by S?
it's not capacitor value. This will be 1 by CS. That will be 1 by 0.04 S, and 1 by 0.04 is 25. That's why this will be 25 by S.
Okay, sir.
This is a current. Because of this a positive terminal, current flowing like that. This will be IS. Then in this case, what is the IS? You can say voltage divided by of all impedances. Voltage is 20 by S divided by all impedances 10 ohm, 0.25 S plus 25 by S. Take LCM, denominator 20 by S. Right, take LCM of S. This will be 10 S plus this is 0.25 S square plus 25. SS will be cancelled out. IS is 20, 10S plus 0.25 S square plus 25. But in the question is asking about the VT value, not a current. Sorry, I trying to find the current, but here they asking about the VT value. Then VT is total capacitor voltage. In this case, total capacitor voltage is this one. Capacitor voltage with initial voltage. This is the VS. You can say this whole is the VS. This is the voltage, the initial voltage, and this is the capacitor. If the IS is fine, then what is the total VS? Total VS is voltage across the capacitor and this one. This minus of this. This voltage 20 divided by Fs minus voltage drop of this one. IS into 25 divided by of S. Okay, this is the voltage. In the question asking the capacitor voltage Vt at t is equal to 1 second. Then you have to find the Vt. Vt will be total voltage, initial voltage plus voltage drop across the capacitor. Because of current flowing like that, that means this voltage minus of this voltage drop is total voltage. That's why I'm doing same thing. Initial voltage minus of this voltage drop is find the voltage. This is 20 by S minus of 25 by S, and what is the IS? I already I find 20 divided by of 0.25 square S square plus of 10S plus of 25. This is 20 by S minus multiplication of this one, 20 into 25 is 500. 500 divided by a multiplication of S is 0.25 s cube plus 10 s square plus 25 s. This is 20 by s minus, I take a common as 20 s, 0.25 s, 1 by 0.25 into s. That means this is the 500 divided by of s square. His term is here s square plus 10 divided by 0.25, it will be 40 s plus 25 divided by a 0.25 is 100. 20 by s minus this will be 1 by s, 500 divided by 0.25, it will be 2000. This will be 2000 s s square plus 40 s plus 100. No need to take LCM to, because of this is already separated, then simply separate this thing. After separating of this thing, you can use the inverse Laplace and find the final answer. You can uh, separate this one in two part because of s square term, two coefficient is there. And how can you find the coefficient? You know about the formula, s is equal to minus b plus minus under root b square minus 4 ac Sridharacharya rule, I think on 2a. Okay, what is the minus b? Minus b is minus of 40 plus minus of
Sir,
40 square is 1600.
sir,
Yes, 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 yes.
sir, can you explain it one more time? From to 20 by s minus 500 by 0.25 s cube plus 10 s square plus 25 s.
Okay, okay. Simply I have common 0.25 into s here. Okay. If you common 0.25 into s, then what happening? This will be 1 s square. 0.25 into s is common. That only s square term is here. Then this will be 10 s square. 10 s square divided by 0.25 s. S will be cancelled out. Only s is there. 10 by 0.25. 0.25 it means 1 by 4. 1 by 4 it means 4 into 10, it will be 40. That's why this will be 40 s. Same thing 25 s divided by a 0.25 s. S will be cancelled out. 0.25 divided by 0.25 is 100. That's why I write I written as s square plus 40 s plus 100. Then 0.25 500 divided by 0.25, it will be 2000. It will be s term is here, s square. Then after I want to break this thing in two part, then use the Siddharacharya rules. This will be minus 20 plus of minus of root of 1600, 1600 minus of 400, it will be 1200 square root of this one divided by up to, it will be 17.3. Then what is the s? 20, once you take the plus, once again another takes the negative, once if you take the positive, the minus 20 plus 70.32, it will be minus of 2.68. If you take the negative, then what happened? This thing minus 20 minus 17, it will be a sin minus 37.32. Same thing if you want to break this one in part of this one, this will be 20 by s minus 2000 divided by f s. You can break this thing in two part. This will be a s plus 2.68 and second one is s plus 37.32. Because of this only r plus 2.68 is equal to 0. Second one is s plus 37.32 is equal to 0. That's why this two thing I written has s plus 2.68. Okay, this is the perfect thing. You have to partial fraction, do the partial fraction of this part only. I use the partial fraction of that one. It means this is a 200 2000 divided by f s plus 2.68 s plus 37.32 is equal to the part of this one a by s b divided by of s plus 2.68 plus c divided by of s plus 37.32. Okay, take LCM. S plus 2.68 and s plus 37.32. What is the this one? S only cancel, remaining thing is there s plus 2.68 and this is the s plus 37.32 plus b. This is the cancel out, only these two is multiplication s plus 37.32 plus c. This thing cancel out, this will be s c s plus 2.68. Denominator term is cancel out, that's why it will be 2000 is equal to square term is here s square, this will be a s square plus these two in positive 2.68 and this here 37.32 summation, this will be a 40s plus multiplication of these two already I have find. Because of these two I have multiplication of this one only, this is the multiplication of these two, that's why I written directly s square plus 4s 40s plus 100 plus this one b s square plus 37.32 s plus c s square plus 2.68 s. Make the square term in one place, a as square bs square plus b cs square plus c. Second term makes the s term on, this is a 40a plus this is the 37.32b plus this is the 2.68c plus again a into 100 constant term. Okay, compare this all thing. Here s square term is not present, that's why this is a plus b plus c is equal to 0. Second first equation, second equation is 40a plus 37.32b plus 2.68c is equal to 0. No s term, a into 100 is constant, constant term is left side, that's why this will be 2000. A is directly find 20. A is 20, then what is the b in this case? B is c minus 20. B c minus 20, then put the value of b and a in equation 2. 40 into 20 plus 37.32, b is c minus 20 plus 2.68 c is equal to 0. 800 plus 37.32 c minus 20 into 37.32. 74.746.4. Okay, plus this will be 2.68 c is equal to 0. These two if you add, then this will be 40 c is equal to 800 minus of this thing, this will be 53.6, and what is the c by 40? 1.34. Sorry, this is the minus c, this is a positive c, no? That's why this will be negative. Okay. Sorry for this, this is the negative. This will be not a 40. The 800 minus of this one is positive, it goes to right hand side, this will be negative, and this will be a 34.64 c. To subtract minus 37.32 plus 2.68, then c is equal to 1.55. Okay, a and c is there, then what is the b? B is equal to minus of c plus 20, this will be minus of 21.55. A, B and C is here. We can put the value A, B and C. And what is the total Vs? Vs is 20 by S minus A by S. A is 20 by S minus B by S plus 2.68. B is 21.55 minus 25.55. That's why this will be S plus 2.68. C is 1.55 then plus 1.55 divided by of S plus 37.32. Multiplication of this one negative, minus of 20s will be cancelled out, this will be positive. 21.55 divided by of S plus 2.68 minus 1.55 divided by of S plus 37.32. Then convert this thing in inverse Laplace. Then Vt is equal to 21.55 e to power of minus 2.680 minus 1.55 e to power of minus 37.32 t. Okay. In the question asking that voltage at t is equal to 1 second. Sorry. Actually, this type of question is asking in the GATE examination. That's why I solved in this also. The Vt at t is equal to 1 second. Now put the value of 1 in place of t. So 21.55 e to power of minus 2.68 minus 1.55 e to power of minus 37.32. We have to find the value, and this is the 1.47 volt. Okay, this type of question is very lengthy, but if you know the concept of the solving this question, then you can go for the step by step and find the final answer. It looks like the lengthy, but if you follow the just step by step only, simply find the initial voltage of the capacitor. Then after use the makes the circuit Laplace circuit. After this one, find the current, and you know about the voltage, total voltage. Total voltage is initial voltage minus a voltage drop across the capacitor. Once you got the equation, this equation, then simply further step is only solving this equation only. To solve the equation, then have to use the partial fraction. If you do, try this one, uh, then it will makes the faster. You practice more in this type of question, lengthy question, and just follow the step by step. Then you can just skip some step. If you practice more about that one, then simply you skip many step to find the answer. No need to all of this type of step, all step. You can skip the step. Very just calculate in your mind only, not write the all of thing. Then this will be make us solve and sort only, not this type of lengthy. Okay, after partial fraction, simply use the inverse Laplace and you will find the answer. Okay, okay, I want to stop here, and next class I want to teach about the AC circuit, response of the AC circuit. It's all about the DC circuit only. I started the AC circuit in next class. I think there is a two class, mine 14 and 16 is there. Both are taken the AC circuit and revision class. One is the AC circuit and another is the revision class of all session. Okay, thank you. Thanks to all.